Okay, this is the video for exponential functions for Algebra 2. We started talking about it yesterday with exponential functions. We made a table. From the table, we made a graph, and we answered some questions about the domain and range. And today we are continuing to talk about it, and this is more with problems like this in context. So this is what you need to know. This is the basic format of an exponential function, where a is the starting value. So we kind of did that yesterday with the problem that we did on the board. Basically, whatever number goes right here is what it would be like. Let me just put like when like the x equals 0, or in our case we said the time was 0, but that's what the starting value is. So if the exponent was 0, it would make this whole part equal to 1. And so the only thing that would matter is this first number, the number in front. Okay, b is called the multiplier. So like if it doubles, it would be 2. Or if it quadrupled, it would be 4. Or if it halved, it would be 1/2. And then this is actually also where you can tell the difference between growth, exponential growth, or exponential decay. And I'm sure you've learned about that in some science classes, or I hope you have anyway, where r is the percent as a decimal. We'll give more examples of this. So here is an example from Delta Math. I took a picture of it. And here we go. So a town has a population of 17,000 and it grows at, so I'm seeing the word grows at 3% every year. What will be the population after 10 years to the nearest whole number? So this is from Delta Math, right? But it's very similar to how you would have it on SAT. So our starting amount would be that 1,700. Oh, and then I just want to remind you, you have the scientific calculator here that you can use on these problems. And then as usual, if you don't understand it, you've got the videos and the examples to follow. And those should help you if my video doesn't. Okay, coming back to this problem. So we would have our 17,000, and it says it grows at 3% every year. So I'm going to go like this. I can see there is this growth right here. So I'm going to do 1 plus that rate as a like the percent as a decimal. So this is how I remember it. Where the 1 comes from is it's like it's saying 100%. And so then if we have an additional 3% on top of that, I don't know if you can see that, then it would be 103%, which would be 1.03 right there. Does that make sense? Because it was 100%. It grew by 3% each year, so it would be 1.03. And that would be our multiplier, is 1.03. So 1,700 multiplied by 1.03 to the power of x would be the generic formula, but we want it for this one for 10 years. So that's often time. The x is often time. So 1,700 times by 1.03 to the power of 10 is what we'd want to calculate. And we can do it. Let me see. We can come back into Delta Math and scientific calculator and then do the 17,000 parentheses 1.03 to the power of, and I don't know if you can see the AB that's on there. Oops, I guess that would work, but I want to close the parentheses first. To the power of 10. All right, and it says to the nearest whole number, so my answer, that's here on the right. Oh, did that go away? Scientific calculator, you were helpful. Okay, so it was 17,000 times by 1.03, close parentheses, to the 10th, and I'm going to have to look at the number. So 228,467, right, because it's whole number. So 22, can you guys see that? Yeah, okay. 228,467 is what I would type in. 228,467. Yes, it is what oh my goodness, what was going on? To the nearest whole number. Did I do it wrong? Is that grows 3% every year? So let me try this again. 17,000 times by 1.03, because that was my growth. And it was to the 10th. 2284. Oh, that's what I did. 46787. Yep, I'm good. Okay. There we go. So I did have it right. I just added an extra number. Whatever. Okay, so then here's the next type of problem. And this is also on those decimals notes. But so we have this, given the following exponential function, identify whether this represents growth or decay. So if you'll notice, there's this drop down and it'll say growth or decay. And the easiest way to tell is this number that is right next to, like that's in the parentheses. I can't point to it. Let me point to it in here. Here we go. So we got 22847, right? Okay. So it's this number right here. So if it's greater than 1, it's growth, which you can see this is not. If less than 1, it's decay. So for this one, it's going to be decay. And we want to know what percent increase, or it'll change to decrease when I do that. So to figure it out, we are going to do 1 minus the 0.974 and figure out what that percent is. What that decimal is, and then change it to a percent by moving the decimal back 2 times. It's very big. Okay, so let's go back into Delta Math and do that. So it's going to change this to decay, and I need to find that number so I can use the scientific calculator. And I'm going to do 1 subtract 0.974, and I get 0. So you guys see I have this 0.026. The decimal would need to move over 2 times, or once you get that, you could multiply it by 100, and then there's the percent. So 2.6%. So right here, I'm going to put 2.6. 2.6. Oh, it didn't like me. Try again. 2.6. Well, still, please. Why is it not liking me? Interesting. 2. Nope. Interesting. Well, that one. I'd put in 2.6, and then it would be correct. I'm not going to do it right now because it's not going to work for me. Okay, then we have the second to the last. The next part is in a lab experiment with a population of 100 bacteria. So that means that's the initial value, and it's able to double every hour. So that means I'm going to come and circle things that I can. Okay, so we got 0.26. Oops, so we moved it twice. So we got 2.6%, and we would want to put 2.6 right there. Okay, sorry to come back to that. Okay, this one. So 100 bacteria, that means that's our A. Double means that our B is 2. So our general format is A times by B to the X. And the one that fits that is going to be this one, where we have our initial value, our doubling, and it says after 3 hours would be like that. So there we go, double every 3 hours. Yeah, there you go. Pretty simple. Okay, the next part is we are going to find the equation of the exponential function represented by the table below. So let me just remind you, the function looks like y equals, or f of x equals, a times b to the x. So where a is the initial value, or it's also known as the y-intercept, slash the y-intercept, and this is the what do we call it? The multiplier. So first thing we do is find the y-intercept right here. This is the y-intercept, and it's equal to, that's when x is equal to 0, so that's equal to 4. So on our equation, we would have 4 first. Now we want to find out what it's multiplying by to get the next one. So from 4 to 2, I can see it was half as much. And then I check again from 2 to 1. Oh, that's again half. And check again, that's 1/2. So we can either have 1/2 here, or you can have 0.5. I don't think they care. So it's going to be 1/2 to the x. Or for this, you could do 4 times by 0.5 to the x. Same thing. All right, so that is what you're doing for this assignment. And the rest of this video is just going to be me trying to, actually no, this is the end of this video. Again, if you need more help, there are the videos and the examples that you can follow on every single problem.